Hey, welcome to the Triangle Linux Users Group. Tonight's meeting will be lightning talks, as most of you should know by now. So our agenda for tonight will be welcome, talk about sponsorship and donations, community announcements, have a job, need a job, call for volunteers. I'll talk about that a little bit. Thanks to those who've already helped, membership, and lightning talks. All right, welcome. I know you all have phones. Some of you have pagers. You might admit to it. Turn them off, please. We'll be doing lightning talk shortly. I'll try and move fast through this like lightning. Remember, tonight we do not have a sponsor. Pizza's not free. We appreciate your donations. We have donation bucket down here. If you didn't happen to see it while you were out there, please toss something in or see one of the steering committee members, which include myself, Michael Rubnak, where Cristobal's back here in the back, Bill, and where is he? Barry. Yeah, he's not here.
He's not here.
And then if you think your sponsor would benefit from sponsoring, or your employer would benefit from sponsoring TriLUG, please talk to them. Talk to us, we'll give you the pitch. We'll make it good for them, good for us. All right, community announcements. I'll go through this fast, but while I'm doing it, think if there's anything you know of coming up that the LUG would want to know about. So in a minute, I'll give Cristobal some time to talk about Ceph, who many of us will realize has touched our lives, but may not know. Some of you may have already heard the news. I'll hand that over to Cristobal in a minute. There's also going to be a memorial bike ride for him. TriLUG on Monday is going to be covering what's coming in Java 7. So if your job involves Java, you might want to go hear about this. There is still some room to have influence over this, but that's Monday, July 15th, out in RTP at the Triangle Research Foundation. On Monday, also at 7 p.m. at Splatspace, TA3M, which is Tech Activists Third Mondays, how to protect your privacy in the age of NSA surveillance. They're going to be going over a rather in-depth post about this and a hands-on hack session with Tor. It's going to be primarily about encryption and how to protect your privacy. NC Tech for Good is a group for techies who work in nonprofits, but in this particular month, they're going to be going over the website of a local nonprofit and helping to figure out how to improve that. So if you have talents in websites, web development, design of navigation, they're looking for help. That's next Wednesday at UNCTV. You can find out more on Meetup. Refresh the Triangle is having a meetup called Make the Logo Bigger. And this is about how to deal with clients when you're a small-time contractor or small contracting shop. That'll be Thursday, July 25th at Bull City Co-working in Durham. Again, meetup.com. And be thinking about Ohio Linux Fest, middle September. Get it on your calendar, figure out your plans, figure out who here you're going to room with when you go.
Why are we more concerned with that than the one in New Orleans? About the same time.
I don't know about the one in New Orleans. So tell us about it.
It's big. It's got a lot of it's got like a cloud co-location going along with it. I think it's called LinuxCon.
Okay.
It's around the same time.
LinuxCon is actually in August.
Well, it's even closer. Be thinking about it harder.
All right. You're right. It's pretty much Ohio Linux Fest ends and this one begins.
There's a road trip for you.
Yeah, maybe we need a TriLUG bus from Ohio to New Orleans. All right, thanks for pointing that out.
Sure, no problem.
Okay, my name is Scott, and thanks for having me. I'm just going to go first here and talk about cracking password hashes on Linux. It's a very cool thing you can do at home. I know y'all like to do it at spare time, what have you, but so I'll go faster. I've got a blog. I'm going to plug scottlinux.com. please go visit and add me to your, let's say Google Reader, but add me to your favorite RSS reader. Great, let's get started here. Okay, so here are the basic overview, quick steps to cracking passwords. First, you will need a word list or dictionary. And that's just a text file that just has a bunch of words in it. Step 2 is take the hashes you want to crack, put them in a text file. And in step 3, you run software, it's just command line software called Hashcat, or there's a version called OCL Hashcat Plus. That works for both NVIDIA and AMD video cards to do it much faster, of course. And hashcat.net is the website. Okay, so word list. So I put a link here for an easy newbie word list. That's random site 360%.com/word list. There's a 8 meg word list there. And I put a note in here, most hackers, or quote security researchers, will have, I mean, most will have gigabyte size of word list. I've got a couple 20 gig word lists, and I'm an amateur. So, I mean, these get huge and can be huge. And typically, the better word list you have, the better chances you are at cracking those hashes. Yeah.
Will the standard user share dict words file work for this, or does it have to be specially prepared and cultivated?
You really need a special separate one other than that kind of one that's around. But these, also if you see like Wi-Fi, WPA word lists, those work with this as well. These are all over the internet, so easy to find. Okay, so you got your word list, you found on some random website, great, that's good. Step 2, you're going to need some hashes to crack. So here we're going to crack, say, WordPress. WordPress uses a very bad MD5. It is salted, but it's still easily cracked, even with this software. So that's what, say you hack the website, got the database. In the database, you see a bunch of usernames and then password hashes. So here I grab the hashes from MySQL database. Different software does different strengths of hashes. Drupal uses SHA 512. So Drupal's much better on security. Django uses combinations of hashing algorithms. So they're all different. WordPress is the easy target everyone likes to pick on, so that's what we're going to do here. So I put those in a text file. And the next thing, so we're just going to run a hashcat command, and we're going to specify the hash type as well as attack mode. These are the 2 basic things it needs. I'm going to go on to the next screen here. I put a note here, you can specify all sorts of stuff, character sets, only lowercase, mix of special characters, you can do all sorts of stuff, but very basic, this is what you need. And so one of those options, the attack mode. Here's the different attack modes, kind of 0 through 5. We're going to do 0 in my little demo here. I'm just going to check straight words in the dictionary against the hashes. And then the brute force option number 3. Everyone thinks of cracking passwords. You think it's going to try AAAA, AAAB, AAAC. Well, you're going to take about 10 years trying that way. That just takes a long time. So typically these other methods work much faster. And there's some fancy stuff this can do if you want to get into it on their wiki. And so yeah, lead speed does not protect you any more than a regular word to a hacker. I'm sorry to say. Okay, and hash types. So we're going to specify type as the attack M. Type 400 is specifically for WordPress. So Hashcat has built-in WordPress cracking. And there's all sorts of different types that I'll show you in the command line here. So in my demo, we're just going to do that attack mode 0, just a straight list, M400 WordPress, my hashes using word list. Okay. Let's dig here. Let me show you the help file real quick. So here under hash types, you see where it starts with 0 being MD5. Here's all the types that can compatible to crack. Of course, these take a long time. You do the LinkedIn's site, got hashes got leaked on the internet probably 6 months ago or so. LinkedIn, they were SHA1, no salt, and people with a modern computer or video card, they're cracking them the same day. So even SHA1 is very poor these days, and MD5 is even worse. But yeah, there's all the types it does, even Oracle database, your Android password or PIN hash. If you grab that from someone, you can try to crack it with this. So. There's my hash file. I only have one hash in here just for time considerations, which should be one. And there's my word list. I don't know if you can see that or not. It comes out kind of small there.
Yes.
And here we go. And there's not really any status. You can kind of press enter at will to see kind of a status. And here's estimating 7 minutes. It's not going to take that long, I promise. Just keep hitting enter. And that 4%, that's kind of estimating going through the word list. Oh, and it's done. So it's recovered this, and there's the hash, and the correct password was. All right. Thank you very much. Yeah, question?
Can you do TriLUG? Do the ones on the TriLUG server?
I actually tried TriLUG and TriLUG 1. I thought that'd be cool for this demo, but it was taking over 30 minutes before until it ever got there.
Shouldn't it try password first?
You think so? If you had a word list and your very first word you put was password, it would just do it.
Have you discerned any quick recommendations for people implementing a password system, like use a hashing mechanism that's designed to take work or some other such scheme?
Right. Yeah, right now, this is your developer, Bcrypt is widely accepted as the best thing. I could even make my password in Bcrypt, and this will take months, probably, because whatever Bcrypt is, it's hard to crack exact.
Unless they put password first.
Right.
That's right. Well, yeah. But also, as I was always saying, having a really long password obviously helps. If you're 8 character passwords, you're easy baits. You want to use 12, 16 characters or more on all your websites, without a doubt.
With special characters.
With special characters, spaces,
Unicode.
because every kind of lead speak thing that we all like to do over 0. I mean, this software tries that as well. I mean, so or @ for A's or O's. That's all sitting baits. So length really helps you. That part.
Hi everyone.
Evening.
This is going to be interesting because a bunch of stuff suddenly came up over the past couple days. Like my company opened a new office and my friend made milkshakes last night. So I'm not exactly what you would call prepared. I have some notes and my laptop, so we'll see how this goes. Anyway, so what I will be talking to you about is how to boot Linux, specifically on one of these guys, an Apple MacBook, using EFI. So I bought this thing 2 years ago for school. I had the grand dream of triple booting, Windows, Mac, actually quad booting. I was planning even more Linuxes, but that kind of fell through because when I was using BIOS compatibility mode, the OS X kept eating my bootloader all the time. And also the bookstore sold me the wrong copy of Windows, so that never really quite worked out. But now that I know about EFI, I am running Linux on this thing full time. So, before I actually power this thing on so you can see what the boot process looks like, how many of you have heard of EFI before? That is not a small number. Okay.
Just define the initials for those who don't.
Extensible firmware interface. How many of you think EFI is an evil plot by Microsoft to keep you from booting Linux on your machines?
Well, it's not only that.
All right, so yeah, there is a lot of confusion about EFI about. See, that was not okay, my computer booted against my will. I don't even.
I blame EFI.
Joining you to the document check.
No, I'm good. So that might actually be a good idea. I'll set it up. I'm familiar with no IT fancy things. Okay, so this is a blur. This is a camera. Okay, this is a screen. Anyway. Yes, okay. So, anyway, so EFI is not in itself an evil plot by Microsoft to prevent you from booting Linux. What EFI is, it's a replacement for BIOS. How many, I assume, if most of you know what EFI is, most of you probably also know what BIOS is. Basically, it's the interface between your computer's firmware, the software that runs at early boot up to control all the hardware and get everything loaded, and the initial bootloader code that's responsible for actually loading your OS. So it was also developed in the 70s, and the basic format is 440 bytes of x86 executable code at the front of your hard drive, and that's literally all it is. Sometime in, I don't know, about the 80s or so, people realized we could do better, and that's what EFI is. EFI takes advantage of the fact that most computers nowadays have file systems on their hard disks. And specifically, it grants the computer's firmware the ability to read FAT32 file systems, plus any others that the vendor wants to implement. Apple, for obvious reasons, lets their firmware read HFS+. And so, basically, what EFI lets you do is it gives you an easy way to have multiple bootloaders of arbitrary size running on your computer without all the crazy tricks that are involved in BIOS bootloaders, like having a stage 1, and then a stage 1.5, and then a stage 2, and also allowing you to and defining a standard interface for manipulating the initial boot configurations from on the OS instead of having a separate protocol for doing that for every BIOS vendor. So what EFI is not, real quick, it is not GPT. GPT is GUID partition table. It replaces the MBR format for how your disks are laid out. I'm not going to talk about that because there's really nothing to say about it, because now using GPT is just as easy as using MBR for your disk. However, it is required for using EFI. And I'm sorry if I confused you with a bunch of initials. But then it is also not the same thing as Secure Boot. Secure Boot is the evil Microsoft plan for preventing you from booting Linux, eventually. And once, but that it is not, it is part of the EFI specification, but it is not required. And even if you do implement Secure Boot, you don't have to implement it in a way that locks people out of Linux. So, now that all that background material is out of the way, I'm going to power this guy up. Please? Oh, there we go. Ta-da! So, this is refined. Notice the capitalized EFI in the top screen. Yeah, refined is a fork of an earlier EFI boot manager called refit. And you'll notice that I have 4 icons here. Only 2 of them actually do anything useful. The other 2 are from when I was screwing around. Yeah, and as you can see, one of them is an Apple logo, and one of them is a penguin. And the penguin one is what lets me boot into Linux. I could make that the default, but I haven't yet because I'd have to boot into OS X to do so. That is green. Okay, let's see if my laptop is willing to display proper video now. Anyway, so, and as you can, and I mean probably for most of you, that looks, hang on, it's loading right now. A computer, got the display port. Ah, there we go. Okay, so for most of you, this probably looks identical to the way you boot your system using Grub, which is you power it on, you got a menu of OSs, you pick one. But the cool thing about but EFI, it's slightly different. Grub is what's known as a bootloader, which is a system with that is run by the MBR. Well, it lives in the MBR, and it's responsible for loading your OS kernel into memory and loading your initial RAM disk into memory. Whereas by contrast, refined is actually a boot manager. And this is kind of a fine technical distinction. But basically, what a boot manager doesn't actually load an OS into memory. It just lets you pick between other EFI applications, which are your actual bootloaders. And the really fun part is that in this case, the bootloader is the kernel itself. I'll get to that in a minute. So, say you want a kick awesome Linux setup like this with gigantic terminal text. First, I need to make it actually all fit on the projector. Step 1 of that goal is install refined. You can get refined from its website. I assume most of you know, can Google or DuckDuckGo or something. But basically, refined is the boot manager. And on non-Mac systems, it lives on your EFI system partition. On Mac systems, it lives on your OS X hard drive. Ah, crap. I really should have prepared better. Anyway, hold on a second. So the first thing you're going to want to do is install refined. Let me mount my OS X. Oh, seriously? Sudo mount. Is it in my history? No. Is it in? No. It is. Gosh darn it! The one time my shell doesn't keep a history of all my commands. Okay. Anyway, I'll just explain by voice. So, you install refined, and and on an Apple computer, you have to do this within OS X. And you can't get rid of OS X after you install it, because if something screws up, Apple uses undocumented black magic to change the EFI parameters. And currently, the only thing capable of changing those boot parameters on Linux has a pretty decent chance of breaking your computer. So yeah, don't get rid of OS 10 as much as you might want to. But so you go into OS 10, install refind. And then the fun part that doesn't require my OS 10 partition to be mounted is the part about the Linux kernel being its own bootloader. So most Linux kernels after 3.3 have a special option enabled called config EFI stub. What this means is that the kernel itself is an EFI application that is capable of loading itself, which is pretty cool. It means you don't need a separate bootloader, and I'm out of. All right, well, sorry for not completing my presentation. All right, I have now embarrassed myself on video for the second time in a row. I tried to give this talk at Barcamp too. It went just as well, and okay, my better advice to you: go on the Arch Linux And don't trust me to give a talk on time ever.
That could have gone better.
Hi. All right, my talk is on iperf and network testing. My name's Farrow. I do embedded Linux professionally. I've been using Linux since the early 90s. Exact date, I think it was when Doom came out. And I'm also on the steering committee. So today we're just going to quickly cover these things. What is iperf? What would you run it on? TCP examples. I've got some use cases that I think are fun. So we'll have a look at that. All right. So why use iperf? Anyone have any ideas? Is my network device working? How do you know if your network device is working?
If you can talk to things.
Right. I'm going to start off with, anyone use ETH tool?
Yeah.
Okay, so ETH tool gives you an idea of what your Ethernet device is actually seeing at the physical lab. In this case, it's connected at 1 gigabit speed and full duplex, and it's got a link, so it's actually talking to a switch or something. That's great, but that doesn't really test your network. All right, so testing for connectivity. Who uses ping? We all know this, don't we? All right, so how do you know what your maximum throughput? Because that's what everyone wants to know, is how much data can they push out their network on their laptop or on their wireless router or whatever. So I have hacked this together in the past using Netcat. And I start up a Netcat server that receives the traffic, and on the client, I start up some sort of process, a list of common tools, just pipe them all together, and I can push lots of data out my network, and I can push them through Netcat. And PB is the little key here. PB is called Pipe Viewer, and that lets you look at what is going through that shell pipe in real time. And you can get progress bars and all sorts of funky stuff with Pipe Viewer. It's all command line stuff, no GUI. And in this case, I'm getting 11.8 megabytes per second out through my interface. But what are we missing? That's maximum throughput. So we want to know what latency is. How long does it take for a packet that goes out to arrive at the other end? Or how long does it take for it to come all the way back and get confirmation that your packet reached its destination? Jitter, if you're doing voice over IP, if you've got jitter or you're doing video and you've got jitter, then your video doesn't go smoothly, or you get crackling or gaps in your audio. And who wants to string together lots of shell commands? I mean, really. So we have iperf. iperf has TCP modes and UDP modes. It's easy to cross-compile. You can run it almost anywhere. So, if you're on Debian, apt-get, Red Hat, yum, install. If you're an emerge person on Gen 2, you can do it that way. OpenWRT, the other night I just thought, well, why don't I just put this on my router? So I'm running OpenWRT, opackage update to get a new package list, search for it, and then install iperf. Quick and simple. It's about 50 kilobytes in size once it's installed. Whoop-de-doo. Right, so I'm going to cover a TCP example. This is pretty plain and simple. I'm going to keep the lists of options to a minimum just for this talk. There are lots of options for iperf. Is Kevin Ott here? No. Because it does do IPv6. So put it in server mode, you put a -s, put it in client mode, you put a -c and the IP address or host name of the server. Okay. So the first thing you want to do is start the server. Simple. I typically SSH into a remote host and start the server on a remote host. And then I start a client on my desktop or wherever. And I'm pointing it to my router in this case. The server fires up and it actually runs along. It tells you that it's connected to your server here. And then once it's finished executing, in this case it's a 10-second test by default, just does a 10-second test. And I'm getting, what is it? Bandwidth 74 megabits per second. Great. That's TCP. UDP. Oh, really hard. Anyone see the difference here? All right, so -u, and it's the same command, just put a -u at the end and off you go. By default, UDP mode does a 1 megabit per second data rate. You can, with options, you can increase the amount of data that you pump out in UDP, and if your network can't handle it, it starts dropping packets, and you'll see that as well. So, start the server, like last time. Start the client up. You get a server report, and you get a client report. At the very end, the server, because UDP is pretty much, in this case, it's one directional UDP, you're just pumping packets out. At the very end, the server sends back a report back to the client to tell you what the server measured. Because if you're missing packets, the client has no idea if the packets are getting dropped. So the server's the only one that can know that the packets aren't reaching it, that it hasn't got all the packets. So in this case, no packets were lost. I'm getting 1 megabit per second because UDP mode only does 1 megabit per second by default. And the jitter is 0.3 milliseconds. So if you're doing voice over IP, this is great. Who does voice over IP or SIP at home? Do you know what jitter level you can withstand before your call goes to crap?
No, it's not my head, no.
I think it's under 10 milliseconds. So if it starts to go above that, you're screwed. This will also show you out of order packets. I've used that before on wireless networks. Sometimes you send out a stream of packets and some packets arrive before other packets. So things get out of order and that can screw up some real-time protocols. All right, I'm going to jump into a use case next. All right, NSA. No. It's a network server appliance, not some government organisation. These devices are typically a commercial off-the-shelf device, COTS device. So what happens is a company buys these devices from some other company, and they stick their own special sauce, their own software on it. They put branding on the front, and they sell it to enterprises and you and me. I was employed to evaluate some of these devices for a company, and we had some problems with it, and I'll go through that. So companies use these network server appliances to build firewalls, to build packet sniffers, to build anti-spam, anything that you can think of. Typically you receive data in one of the Ethernet ports, and then you work out where it's got to go on the other Ethernet ports. You may have demilitarized zones or whatever. There you go. Inside, it's basically Intel architecture, and I'm going to rush through. And you would think it's got 8 identical Ethernet ports at the front. Bang, bang, bang. No. Okay, look at the back. We've got a VGA port. Great. And an expansion slot. It's starting to look more like a PC every day, isn't it? Okay, so they build these things with a modular design. They want to make sure they can make one base unit and then sell different models of it to various people. So this one had 4 ports built in. They were actually on the motherboard, and they were all each network chip was connected via PCI Express. And PCI Express is a point-to-point architecture, like a star architecture, not a bus. It had a 4-port card for the other 4 ports, which is PCI or PCIX, which is a bus. Bad performance. I've gone too far. The PCIX, they had a PCI Express to PCIX bridge. So they had one PCI connection to the bridge, and then the bridge had 4 network chips on it. And performance, you would expect to get, in this case, gigabit performance out of it, but you got much less than that because it just couldn't sustain the throughput. And I've gone over 10 minutes, so I'm dead. And if you want to look at this, this is another one I've used. Embedded system, video processing, but I'm done. So. Skip the end. Thanks, everybody. Who's up next?
Is there somewhere we can look at your slides?
Try Choke.
Okay.
Are you going to upload them anywhere?
Okay. Jeremy sent me an email, so I'll just pop that up. Wrong screen. All right, let's see if we can do this. Yeah. Oh, the microphone back. You could. Yeah. Press the top button once and it'll appear with me.
Can y'all hear me? Yep. All right. Well, 2 things I want to talk about real quick. First thing is bar camp t-shirts. I've got a suitcase full of them. How many people here went to bar camp and registered for a shirt and did not get one yet? Just get with me after the meeting or whatever, and I will let me know what size you need. I got them in the car, and I'll get them for you then. All right. And the other thing, the signs. Is there anybody here that would be able to take over the sign, put the sign up? You'd be able to?
Unless there's a volunteer. It's not on the CSB.
Anybody want to be on the break? That's an easy one. Okay, well, all right. So I've got an electric car, and and I've also done a lot of just reading online about open source cars, and I'll talk about that a little bit. Has anybody ever seen this car? Anybody know what this is? It's the Rally Fighter. Nobody ever? Okay, well, good. So there's a company out there called Local Motors, and they make this. They use an open source concept to build these cars. But I'll get into that here in just a bit. I threw this up here. I found it last night when I was pulling this together. It's kind of interesting. The reason why I thought it might be relevant. This airplane flew from, I think, the west coast to the east coast, and it flew overnight. It ran completely on solar power. So it's like the first time anything's flown solar power flight. And it's supposed to be able to fly around the world. They're working on a around the world flight.
It flew overnight?
It flew overnight. Yep, it took off during the day, charged during the day, and then it flew through the night, and it was still flying the next morning. So,
But it does land. It's not.
No, those are sweet solar panels if it did.
yeah. Well,
That's only flying 45 miles an hour.
Yeah, yeah.
It was a full
Well,
moon.
Huh.
It was a full moon.
There you go.
I guess a lot of money's been dumped into the research. I think batteries have, the cost, they're starting to manufacture more, and I think the price of batteries, energy storage is half as much as it was 3 years ago. So there's a lot of progress being made on electric stuff, and you're starting to see that in the cars. I found this on the Department of Energy. I stopped at Nissan yesterday and talked to a guy there that was an expert on the Nissan Leafs, and he told me to look at the Department of Energy for some information. While I was talking to him, he told me about there's two companies that work here with NC State. This is one of them, Advanced Energy. I think they work with the Freedom Department or something here. So whatever I talk about here, if you're interested in this kind of stuff, NC State has some. And ABB is the other company that they talk about. They've actually had their headquarters in Cary, and they got a level 3 charger there, which is something I'll talk about here in a minute. But they're also working together with NC State. They donated $1.2 million for it, but they're really big into this electric car initiative. And they actually just landed the contract to put charging stations in the Netherlands, I guess. Yeah. And they're going to put one, so every car will be within, no matter where you're at, they'll be within 30 miles of the charging stations. And I guess there's a design of what those things look like right there on the right. I'm going to publish this link, and everything I talk about on here has the article where I got it from at the bottom. So if you're interested in going back looking into this up, where it came from. So Tesla is making electric cars. You may have heard of them. You may have heard of SpaceX. SpaceX is that commercial company that's doing commercial space flights and stuff like that. I think the guy that's one of the engineers that started PayPal, I think, is founded SpaceX and Tesla. And
It's the guy that drew that quote up there, Elon Musk.
yeah, that's him. That guy. So they're building a network of supercharger stations. So by the end of the year, you should be able to do a cross-country trip in an electric car. And their supercharger stations are really fast. I think they charge in like 15 minutes or so. So you can get a full charge. So that's kind of where I mean, I've got a car and I commute with it every day. It's good. It doesn't use any gas. And it's fun to drive. It's got a lot of power and everything. So the only thing we're waiting for now is just to have more locations to get charged. So this is one of Tesla's cars. It's the Roadster. It goes 0 to 60 in 3.7 seconds. It's pretty quick. In the beginning, before I bought an electric car, I was just doing some research, looked online about maybe converting a vehicle over, and they've got all kinds of conversion kits and things like that. I decided not to go with that, and I'm glad I didn't. There's a guy down in Stanford that actually has a car shop that does that sort of thing. Right now they got government incentives for electric cars. I got $7,500 off of it, and that incentive will last until they sell 200,000. They've sold 50,000 so far. North Carolina does a tax credit up to $1,500 for a level 2 charger, which is a 220. It'll charge your car a lot faster. With the new cars, it'll charge them up in 3 or 4 hours. With a year-old car, it'll do it in about 7 or 8 hours. It's got a phone app. You can turn the climate control on. You can set it to like turn the air conditioner on or the heater on in the morning, like especially in the winter. So when you get in the car, it's already been running for 15 minutes and heated everything up. That's kind of interesting. It's about $15 a month. I was paying $140 a month in gas, and now it's about $15 a month for electricity. And that's about what you pay. So they lease these things for $200 a month. So no oil changes, no fuel. It costs about what my gas and oil was costing. So it's got a navigation system on it and like a backup camera system and all that. But it tells you where all the chargers are. So if you're not sure where the nearest charging station is, most of the charging stations have like a GPS location put in, or they just plug it in when they set it up. And it's extremely quiet. They actually had to put a whirligig in it. They put some sort of thing that makes a whirring noise so you don't run into pedestrians that don't know you're coming. So there's grants in place to incentivize companies to install charging systems. So what I think is, if some of these companies get involved, Whole Foods, McDonald's, Cracker Barrels along the highways, they're starting to adopt these because when you go in someplace, you're going to be in there for 30 minutes anyway. Usually, like a level 3 charger is a 440 that the commercial places would put in. That'll charge your car to a full charge in 30 minutes. So if you go into like Walmart or somewhere like that, it'd be charged up by the time you come back out. And most of your charge, even if you don't have 4 hours, most of the charging time, most of the charge, you get that in the first hour or so. And I'm not really advertising for Nissan or anything like that. So, but if anybody does want to buy it, if you use this guy that I use, I get $100 and I'll donate it to the pizza fund or something. So got your attention. And there's a fan club there that you want to go check it out. So the chargers, you got 110 volt. That's what I'm using every night. I commute from Apex to Raleigh. It's about 23 or 24 miles, and I go to lunch. If I need to, I drive a little bit when I get home. So it's a good commuter. I've got another gas vehicle that, if we're going out of town, that I use. My wife uses it. 220. Like I said, the new cars, the 220 level 2 charger will, 3 or 4 hours. The older cars, about 8 hours, 7 or 8 hours. The level 3, it'll do it in 30 minutes or so. And there's it should be about 15 minutes on those supercharger stations or whatever that Tesla's putting up. Fun things to do with an electric vehicle. Go to Midas and tell them you must have fell off. Or go to Jiffy Lube and ask for an oil change. It's always nice driving past gas stations. It's nice to silently accelerate all the gas cars because it's electric car has more torque than gas or diesel. So you just leave and they're way back there. And you just don't even hear it or nothing. You just 1 minute. And mine does about 90 miles an hour. So, tinfoil hat alert. It's got a lot of. It communicates with like the mothership. I mean, it's got software on it. It's got wireless. It transmits your GPS data and stuff for research purposes, they say. And it's got a microphone because it connects with your phone. It's got a camera, so if it's got software, that means it can be hacked or whatever. So that's kind of a concern.
On the other hand, I mean, gas cars are having this now. And
so gas cars get it too.
So if you're going to get spied on, you might as well get spied on in a car that has less operating costs.
Right. Yeah.
You're out.
You're out. Oh, am I out? I never even made it to the source cars, man. Oh. Well, anyway, all right. Local Motors has. Can I just? All right, Local Motors. They got open source cars. Let's see. There's a software company that's trying to advocate for open source software in open source vehicles. They made a Domino's car. They did a petition there, I guess the states are fighting electric cars because it's not good for the gas companies and stuff. And this is a really cool video. Jay Leno, he interviewed, checked out the car and all that stuff. So this is an open source car. They do like a micro site where you'll build like they'll build like 2,000 cars in a local area. So instead of having like these huge companies.
I've got a real quick question about the network of chargers.
Yeah.
Have they arrived at a standard? Because I remember at least a couple of years ago that the charger that would be used by Tesla was somewhat different from what the Japanese companies wanted to use. I don't know if they ever reconciled that or.
They're still working that out, and they're supposed to hopefully come out with those this year. Say.
The level 1 and level 2 are standard. Level 3 is different.
Yeah, the level 1 and 2 are the same connector.
Yes.
You know, so they look the same. But now mine came with a level 3 charger, the Japanese style one. So if they do go with that one, it's already ready to go. So.
William Chandler, you here?
William Chandler?
Is it on? Okay, cool. Is that it?
I'll give you a 2-minute warning.
Okay. Is that the play?
F5 will,
F5. Okay.
Exchange.
Yeah, all right, cool. All right, I'm William Chandler. I'm a systems engineer over at Wake Tech Community College. I'm mostly responsible for the networking, and so these are some of the tools that I use to make my job a little bit easier. I don't know if you'll be interested in it or not. Some of the tools, Pinger is a tool that I wrote. I'll get into it, but Pinger, MRTG, Smoke Ping, NTR, IFTOP, and iperf are all tools I'm going to talk about. Pinger, it's a custom web app written in PHP and JavaScript. I wrote it to try to make it as simple and easy to use as possible. I wrote it to use ICMP or do a TCP UDP check. It's just using like sockets. It's a PHP script. It's making a system call to either ping or NC to do the actual check. It's instance-based, so I can load it up on my laptop, and it's a completely separate instance if I load it up on my phone. So that way, my laptop will be doing the pings, and my phone will kind of be doing the pings, but it's really just making a call back to the server. So yeah, I don't know. It seems like it'd be lighter, and it wouldn't rely on like a daemon on the background. The configuration is just XML, pretty straightforward. I did 3 layers of nesting just to organize everything. This is it. This is some of the switches that we are monitoring. I monitor about 200 switches roughly. This is them all up. This is a lot of our email system. It's running Microsoft products. So that's always good. And then these 2 guys here are Linux, and that's our Guardian and spam protection and all that stuff, which is up. Running good. Those were all ICMP ping checks. These are socket-based checks. These are doing checks on like port 80, port 443, port 25, and RDPs. And then some of the core services that we have, DNS, LDAP, and secure LDAP, making just NC calls on those ports. This is real quickly the configuration sort of setup. You know, it gets more in depth, but I try to make it as simple as possible. The layers are kind of intuitive. You go devices, then what you're wanting to do, either a ping or a socket test, and then switch is what category, then core is category, and then devices. So that was that tool. Then MRTG is an old and mature tool written in Perl.
draws pretty little graphs, collects values from SNMP, or you can do a custom command. It runs as a daemon and a poll, usually about every 5 minutes. That's pretty cool, but I don't like that. It can create a daily, weekly, monthly, and yearly graphs. So it allows you to get information, like historical information. So that one on the top left is our internet connection to the big bad internet through MCNC. We have a gig pipe, and this was taken, I think, today, and we're only hitting around 300 meg. One of our connections to one of our other campuses is on the top right, is going, that's our north campus, and we're only hitting about 100 meg. But you can kind of see the traffic patterns throughout the day. It spikes up around 8 in the morning and then slowly trickles off. So we can kind of tell roughly how much the network is getting used. This is a little bit more of a breakdown, the weekly graphs and monthly graphs, so we can kind of get more detail out of it. Smoke pinging. This is another little tool that has been talked about on the mailing list before. I know some people were trying to get it running on their Raspberry Pis. It's pretty cool. It graphs the latency from pings. It'll run as a daemon, so there's continuous polling going on, and it uses fast CGI for the web front end. This is a quick little, these are some of our external hops that I use it for, to make sure that, it's just, historical information again, just so that way, it's I guess, a consistent latency. There's a bunch of external hops that we're checking. The way that MCNC is set up, it's kind of got a ring architecture, so we can either go out through RTP or we can go out through Charlotte, or there's another hop in Winston-Salem that we can go out of, but that's actually going back to Charlotte, but whatever. Anyways, yeah, so there's a bunch of external hops that we're doing to check, make sure where it's going and what's going on in the background. This is a breakdown of one of the hops. Gives you the last 30 hours and the last 10 days, and then something else after that, I can't remember. But do you remember Google's outage yesterday? Google is actually a peer with MCNC, so they got a line directly into Google, and that's one of the hops that we're checking. And right there is when Google stopped responding to a lot of traffic. And that's pretty interesting. And that's another one of the Google peers, and it's completely gone. So, yeah, I don't know what's going on with that. All right, and then MTR, it's my trace route. It's just trace route with fancier. It'll continuously loop, so it's continuously running a trace route. So you say MTR yahoo.com, and it'll continuously run a trace route against Yahoo. It's cool because it gives you good information. There's a command line version or the GUI version. Usually by default, there's a command line version. So you usually gotta say like MTR install or whatever. But this is the GUI version. Yeah, that's going to Yahoo. Bunch of hops, bunch of losses. Good stuff. And then that's the command line version. Same thing, only it's run from the command line. Then ftop and iptraf. One of the things that we try to do is keep an open internet at Wake Tech. We believe in academic freedom, but there's certain limits to that. You can't just, we have a gig pipe, and if you're trying to use all gig of that pipe, we gotta kind of look into that. So it allows us to provide or get more detailed information about individual users or clients or a server, whatever the case may be. The way that we set this up is we just set up a mirroring interface on our core switch. It goes, so we have it through, so we can break it down in just a little bit. We can go from one campus, or we can go all the way out to the internet, or whatever the case may be. Like I said, we try not to be evil. We're not the NSA. We don't retain any packets, so that's pretty nice about ftop and iptraf. You don't have to, it's not like Wireshark where it really drills down. But this is ftop. Kind of tells us that nothing really out of the ordinary on this one. This is monitoring our North Campus. The NWS monitor is those little video conferencing systems. So looks like we got 10 seminars going on probably right then. Each of them eating up about 4 megs of bandwidth. So that looks pretty fine, no big deal. This is iptraf. Again, really nothing too detailed about this, but it allows you to figure out which users are using up as much bandwidth as they are. So, yeah, good stuff. And then there's all the links for that information. And if I can get this to work, I'm gonna try to get my work stuff to show up here. Maybe.
2 minutes.
Okay, cool. Yeah, so this is the pinger. It's actually running on my work network right now. As you can see, BBBF1 keeps going up and down. It's actually sitting on a Hyper-V hypervisor. So thank you, Microsoft. But yeah, these are all the switches that it's monitoring, roughly 200 switches. It's running just fine. There's usually about 4 or 5 instances of this running from each of us having it up continuously. This is smoke ping again. So we got like all these external hops that we can monitor. Gives you really some detailed information. Oh, come on. And then some of the internal hops. So that's that guy, and then MRTG. And then if you ever want to see what we use throughout the year. Yeah. So yeah, that's it. Cool.
Alan?
So it says it's mirroring the display, but that's not what I'm looking at.
Should we start his time now?
Yes. So you guys might remember at one of the parties we had at Splat Space, I talked about a tool called Backup PC. Well, this thing says it's working.
Can you use a document projector?
Actually, if we just have a thing that's hooked up, I can pull up a quick website rather than talk. So you might remember I talked about Backup PC. I'm a little bit of a backup pervert because in 1995 I had this DOS PC. You know, we all had DOS PCs back in those days. And I had a zip drive, and I thought it was really cool because you could hook it up to the parallel port and you could store 100 megabytes on one disk. That was pretty cool, right? So I thought it would be a neat idea to write some little batch file or something on this zip drive that when I plugged it in, I could say, back up my stuff, and it would copy just all the good stuff off this DOS computer onto the zip drive. And I was testing it out, and yeah, this thing worked okay. And then all right, so so the next night, you know, that night I went to bed, said, that's fine. Get up the next morning, turned on the computer, and I heard this tick, 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 tick,
Click of death.
and knew exactly what that was. But fortunately, I had a fresh backup that I had made the night before. So I decided at that time that backups were a really good idea. Okay. Because
It's not mirrored, so you know.
oh, okay. Oh man, it's got one of these crazy mice things. Are you gonna take this out of my time? Oh, this is nuts.
This is 2 minutes warning, isn't it?
Yeah. All right, so anyway, we're going to progress a little bit. You guys have also heard me give a talk about the oven place. So when I was working at the oven place, TMIO is its actual name, it was about the same time I started coming to TriLUG meetings, and there was a bunch of talk here about backing up a pilot and the other machines using a script called RSBack, which I thought was a pretty cool idea. It was a wrapper around rsync. And so basically it would store today's backup in a directory called daily1, and it would store yesterday's backup in daily2, and so on, and go on back. And it was kind of clever in that only the files that were different took up any more space. And the files that were same were actually hard links between the two directories. So they're only stored in one inode on the disk, but there's two directory entries for them. And it was a very clever little way of deduplicating data. And that facility is built into rsync. And RSBack was just a little Perl script that wraps around rsync. And I thought that was a pretty cool idea and used that for a while. But one of the jobs that I was asked to do at the oven place, I love the way everybody's looking at this config file that has one line in it. But,
can you make it bigger?
Oh yeah, sure. If you want me to read it out, top there equals backup. So one of the jobs that I had to do at the oven place, we had a factory there, and everybody had these Windows PCs, and the boss said, I want all our Windows PCs to be backed up. So go figure out what tool I need, and go buy it, and then go put it in the factory. And so we looked at all these different tools, and the one that we ended up settling on that we liked the best was called Backup PC, and that's the one that I talked about at SplatSpace. And I still like the tool, it's really awesome. It gives you a nice little web interface to just say, I want to back up this directory on this computer every so often, and this directory on that computer, and go do your thing. And so I ran this on a Shiba plug. Does anybody here know what a Shiba plug is? Okay, so it's about like a Raspberry Pi, but it was made probably 2009 time frame. It's a little plug about this big, and it's just got an ARM processor in it, and it runs Linux. No hard disk or anything, so you go out and you buy yourself a $100, 2 terabyte drive or something, stick the thing together, and you've got a backup solution right there. So I ran Backup PC for many years and thought it was a really cool idea until I got this new laptop, and I had a directory on here with 100 gigabytes full of just crap that I've just collected over the years. And it's light enough where I would carry it to work every day. So I'd come home and I'd set the thing down and I'd go off and do my thing, and Backup PC wakes up every hour. That's the way it works. And it says, well, who haven't I backed up in a while? And it says, ooh, here's a new one I haven't seen. I'm going to start backing you up. And it would start its deal, and it would keep going and keep going and keep going. And the next morning, I'm sitting there getting ready to go to work and brushing my teeth and looking at the backups and saying, it's still not done. Come on, let's go. And finally, I just yank the thing out and just go to work and say, forget it. I'll get it tomorrow. And I got to the point where it would never finish the full backup because it was supposed to take about 30 hours. And the only time I could even do that was on a weekend because, I'd take it to work every day. So this Backup PC thing wasn't working. And I tried to figure out what the problem was. Was it the USB drive, or was it the ARM processor, or what was the deal?
1 minute.
And 1 minute?
So give him 2.
All right. So finally, I decided it was the way Backup PC was working. It was compressing everything, and I decided to go back to RSBack and just compare it between the two. And I didn't really like RSBack's configuration file, so I wrote this script that says, for this computer, put these things in the config file and then go run. And then for this computer, go put these things in the config file and go run. And then after a while, I decided there's no reason to even run RSBack at all. I'll just call rsync myself. And so the result of this is a program called Flashback. And it's a Python-based daemon. It runs 24 hours a day on the Shiba plug. Its job is to go through a list of computers that you've specified in a directory, in a config file that looks like this. And here's one host, 3 volumes. Here's another 1.5 hosts with a few volumes on it. And then Bender over here, my file server at home, has a whole bunch of volumes. And every line in there specifies a job that it's supposed to do. And so what it does is it tries every single one of these, and then it sleeps for 10 minutes. And then it wakes up again and tries them again. And if one of these things says, wow, this thing's too big. If it says, I'm supposed to do this every day, then it looks and says, if I've got a backup that's already less than a day old, I'm not even going to bother. I'm fresh. And when it runs through this is the status file that it generates. So you can see that the computer called Aspire has been off for a while because every time through the loop it fails. And I made this on the 7th, on July 8th. And you see that the July 1st was the last time that computer had been backed up. But basically every 10 minutes it goes through this list. It's sorted by the time of the next backup. And it says, these up here are the ones that it's going to try, but this says next run in 1 day, 2 hours, 15 minutes. 0 days, whatever. Anyway, you see that it's sorted in order of when it's supposed to back these things up. So that's the entire user interface of this Flashback program. You set up all your jobs in one file, and then this output file just gets written to every time any status changes. And you can look at it on a web server. You can just point your web server to that file, and this is the output you get. But the really nice thing is it tells you how long it takes to do these backups. And you see this one over here. Is it Digit Users Daily is the one that just succeeded? That's the 100 gigabyte partition on here, and that took 19 minutes. Now it didn't back up 100 gigabytes in 19 minutes, it just backed up the stuff that changed. And the difference is, Backup PC had to go through and uncompress all that stuff to compare it to the stuff that was on my computer to say, no, I don't need this, no, I don't need this. And it spent 30 hours just uncompressing and comparing, when really all it needed to do was do a couple of quick checksums in 19 minutes. Now, I suppose I could have told Backup PC not to compress, and I might have gotten similar results. I don't know, because I never got to that part of the test, because I was having fun with this. But anyway, the goal is to take this, open source it, send it to, make a Debian package out of it, host it on GitHub, and let people use it. And my first guinea pig is right back here. He's trying it out and got it installed yesterday. If anybody else wants to play with it, give me a buzz.
Alan, have you given any thought to off-site backups?
Yes. Both at the other place and currently, with stuff at home. And basically, it would be the same thing as this, only what I would probably do is back it up once locally, and then one of the jobs would be back up one of the local backups off-site. That stuff takes forever, and you probably want to seed it by taking a
or
hard
only
disk
the
copy
really important
first.
stuff.
The other thing you'll notice, well, you may have noticed on the list of backups back there, the one at the bottom of the list was actually Pilot. Right before we did the upgrade of Pilot back a few months ago, I spent the 3 weeks prior to that using this to make a backup of Pilot, so that we had something fresh. Now, it ran for 3 solid weeks. And then when we got to the data center, I took the hard drive in there and did one little final rsync to get the last few files that changed. But that was one of the tools that I used to get our backups before we upgrade.
So Alan asked for 5 minutes for his talk, and I think we went over 10.
Yeah.
But technical difficulties.
There you go.
You in?
Let you down.
Anyone else got an old MacBook adapter?
I think I prefer old.
As in DisplayPort?
No, it looks like GDI high to VGA.
Too small.
It's not a mini display.
Hey!
I have it.
No.
But what format's it in? Open office. Okay. Hold it. Do you want to put the microphone on?
Actually, Actually, I'm embarrassed to be presenting with an Apple device here. I'm from Senegal, West Africa. My name is Moustapha. People sometimes say Moustapha. The intonation in a different place. And usually when I go back home, most people run winter machines and they have windows. And I always tell them that they need to free themselves and run Linux. And when they see me with an Apple today, because I forgot my Linux machine at home, they'll be laughing at me. But
I'm going to give you 10 minutes.
All right, thank you. I come from a small village of rice farmers, and when I ran into Linux in Ann Arbor, Michigan, I was quite happy to see that there is an operating system that is free to be able to plug that back to people back home. And that makes it that I'm quite excited to share something that is about our survival, which is about food, housing, energy. When we talk about open source, we think about PC board and microchips and all that, but there is a whole lot of things that is going on around the world when it comes to even building your house and how you eat your food. So my focus today is going to be on something that is called permaculture. Who heard of permaculture in this group? Okay, couple, that's good. So what I'm going to talk about is mainly design, how to use different type of designs and free yourself from corporations and a lot of control that is done in our life today. So really, I'm not inventing anything. Pretty much what I'm doing here is that I'm sharing. In 1995, I came here in 91 and was reinvited. I was here as a student exchange, and it worked out well in 91. I was reinvited every year. In 95, I discovered a permaculture institute in Colorado, and I went there to take a permaculture training. So what it is that it's an ecological design that uses a lot of the way nature works to really take care of our needs. So I'm passionate about really high quality lifestyles. I come from a family where you made your bed, not the way we make it here. You pretty much made 4 branches that you stuck in the ground inside this mud hut, and then you put branches together. I mean, on fork, the stakes that you put down in the ground have a fork on top. So pretty much it's a bunk that you create, and then you take a burlap bag and tear it apart and make with 4 burlap bags. You made your mattress. So there's your bed. So today, to live in an energy star house, which I'm sometimes afraid to show pictures of my house with my family because they'll think like I'm a millionaire or something like that.
Press the spice bar.
One thing that I believe people need to look into is building their houses with cob. It's pretty much clay and straw. People think, well, you cannot do that in this type of environment because it rains a whole lot. Well, in my country, it rains a whole lot more than here. I'm in the rainforest on the southern part of Senegal. But pretty much the key is that a house with a good hat and a good shoe will withstand any rain. And of course, location is very important. If you put it on a stream, it's not going to last. So this house inside, I mean, is not that different from my Energy Star house in downtown Durham. It has pretty much all the nice quality furniture inside. Another technology that I want to share here is building the house with a dome using Adobe bricks. This here use actually compressed earth blocks. So you're taking a compressor and with hydraulics putting a whole lot of pressure onto mud, and you have a pretty nice brick, and use a technology, a certain technology that I actually went to India to learn how to make vaults and domes. So it's a technology that doesn't need a whole lot of equipment. With plumb line, a square, and what do you call a ruler that has like a bubble inside it? A level, okay. That's pretty much what you need to build this. So look into this. This one is at CalEarth in California. 4 minutes. Okay. And this one is built out with just plain Adobe bricks. Plain Adobe bricks. This is not even compressed. This is just a form with wood that you fill up with mud and let it dry and build this one without any high tech. In December, I was in India learning the technology, and it's very, I mean, they taught this to a 14-year-old girl, and she could do that. So I believe everybody here can do that. This is my teacher's living room. Again, sometimes when we hear dirt house, we think ugly or just functional. You can see how beautiful that thing is. That one is called a pointing dome. Again, technology, if you never dealt with it, it looks very complicated, but it's very simple. Energy is something that we're quite addicted to, so there are a lot of simple ways to deal with that. That's an oven that actually, it takes 15 minutes to heat it up. Well, my oven takes about 20 minutes or sometimes more. So with 15 minutes, with something built out of dirt, you end up with, this is called a barrel oven. With just brushwood, you can bake your food. In Oroville, in India, what they did is that they bought parts of bikes, this part here and this part here, and then they just manufactured this with a battery in here. You can definitely have a nice ride to work and back without having to pay anything. With just one solar panel, you can charge a 12-volt battery quite easy. Of course, for transporting your goods, a pretty easy device to make. That's the living room. Talking about energy again, that's the living room that is heated up with something that is called a rocket mass heater. It's the same technology as the oven I showed you earlier, and then the pipe from the flue is run through this bench here, and then it heats up this place, so you're sitting on a heated seat just like in the car, and at the same time it heats up the living room. about our food, of course, that's not what I want us to be eating. And that's not what I want us to use to grow our food. The Native American had something that is called the Three Sisters. And you have squash and a bean climbing on the corn. And then with these three items, you have a decent amount of protein and sugars that your body needs, and easy to grow too. And the way we do growing food in permaculture, we copy on how the forest works. So pretty much instead of rows, which pretty much that is copying how farming is done, the rows was set for being able to use machinery in between the rows. But in the forest, when you walk in the forest, everything is growing with a lot of layers used. And even, of course, the pests get confused. But in your garden, of course, the pests will just line up, and a little bit of explaining how the layers are stacked up to be able to maximize how to produce your food. As for waste, anything that comes out of your kitchen can be handled by worms. I'm sure many of you heard about vermicomposting. There is something a whole lot better than that, which is black soldier flies. These flies actually don't regurgitate things on food like the house flies. These flies don't bring any nasty thing to your house. Their grubs will eat, when you have like a square meter, they'll eat about 17 pounds of waste. And the waste can be human waste, it can be scrap from your kitchen, it can be your garden lawn that you clipped, and you can put it in that, and then they'll produce a nice compost for you. Anyway, I ended by sharing this is where I come from. It's huts again. It's not like what we have here. It's huts. But the way we build, we create a situation where you have to work in a community. And one thing that I like with the Linux user groups is that there is a lot of great sharing. And that's really what I call social security. In our community, if your house burned down, everybody gets together to build your house. So in no time, you get a brand new house. And I want to take this opportunity to thank him for saving my sister's data. That was last week. Again, back home, your house burns down. Everybody steps in and saves your stuff. So I thank everybody here for their help every time I'm putting something on the Linux user.
Jack, you're up.
Excellent.
I mean, I was going to use your machine, but I guess it's a mic. No, I need a website.
Sorry. Yes, and then drag it that way. Or you're going to mirror.
Oh, your mouse doesn't work. You're one of those.
I bought a Lenovo X2200, whatever laptop, and the touchpad just drives me mad because when you leave your palms on the front, the button, it presses the button.
You know there's a daemon you can run
Thanks.
to
Yes.
measure the.
Good. So I disabled the touchpad and it drives him mad because he's got to use the little nub mouse thingy in the middle of the keyboard. Yes, there is a daemon that you can run that when you type on the keyboard it disables the touchpad, but it doesn't.
Bill, maybe you're better at this. I want this last file. I want to open it in LibreOffice. Or I thought I did, but it's your machine. Sure. Anyway, so I'm going to be talking about Ceph today. This wonderful guy, Sage, from out west, created. He also is one of the founders of DreamHost, and this was one of his research projects at university. And I asked on the IRC channel earlier today for some nice graphics, and he said, "Here, I get a presentation at TriLUG. Why don't you use mine?" Fine, they're very pretty. In addition to being a 4-node, in addition to all the actual great storage technology, they have wonderful, I think, documentation. And a very active mailing list. I signed up for it. All I read now are emails about Ceph. So, great. So Ceph's design goal, yes, is to really meet the needs of storage today and going into the future. We've gotten more and more things we need to store, so it's really supposed to be infinitely scalable, which is interesting when you think about it, because scalable to large quantities is different than infinite. One of the favorite presentations I saw, they were talking about having a infinitely sized hotel. Where you start with a regular hotel, you have a reception desk, and if you need to double the size, triple the size, you add more receptionists. But when you have a hotel with billions of rooms, that just doesn't work. You need to go out a different way, because hundreds of thousands of rooms will be on fire at any one time. So that's kind of the idea of the scale you have to think about. Sage is really big on making this new technology open source. Because when you have all your data locked out per minute, petabytes of data, you don't want to be beholden to the vendor who sold you the expensive widget. So a little bit about the architecture. It is in mainline Linux. The server components are all user space, although not to my knowledge have they been used outside of Linux. But they're in kernel clients as well as user space clients. So it's built on this low-level object store where objects replicate between the different hosts participating in a cluster and automatically distributed. We'll get into that later. But on top of this store, they have several exciting applications that are built on it. This is sort of also the layer that it's C library for actually accessing the store. So you can build your own clients, use it directly. In the HPC world, POSIX file systems suck. You don't need all that metadata. If you're writing the application from scratch, go ahead and use the API. Swift, S3, so traditional cloud offerings that you want to store. Hey, store this thing. I don't care about any metadata. It's a CGI you run, stores the data in Ceph. RBD, and these first two are the ones that are stable now, ready for production now. RBD is a block device. So you see this used for mostly VM images, but if I need to provision a 40 terabyte file system to one of my servers, great. Do I have it in my petabyte cluster? These are integrated well into OpenStack. The one that's up and coming is the one that everyone's excited about, is a POSIX file system. Everyone needs files. Ancient stuff never goes away.
So this is the thing they want to get rid of. Expensive, two things to fail. Doesn't scale very well because you still have to go through a central location. So there are, yeah, question.
You went very fast.
I skipped it because I'm using someone else's slide now.
Okay, got it. Continue.
Yes. So in building Ceph, there are two main components. So there's the things that store the data. These are the things that have disks. They're called OSDs for object storage daemons. And unlike a traditional storage architecture, where you may have the disks put together in some fashion by some RAID technology, Ceph is designed to do the replication itself, and so every disk you just have an OSD associated with it. So if you have a host with 5 disks, you have 5 OSDs, and they can store objects on the disks. And then, right, so each that would represent the host. The M's are monitors. So they monitor the state of the cluster. The OSDs gossip between themselves and report their state to the monitor. So if one goes down, everyone knows about it. Action can be taken. So what happens when I need to store something? Well, traditionally I'd have to go through some sort of central location to look up where it goes, but that doesn't work well at infinite scale. So the clever thing they have here is this crush algorithm that will take the thing you're storing and the state of the cluster and compute where it ought to go. That's why the monitors are for, because you need the state of the cluster. But once it's computed where it ought to go, that's the maroon object goes on those, and the other ones get distributed evenly across the cluster. Internally, there's a concept of placement groups where something gets shoved in a placement group, and that placement group is distributed amongst them. And if I need to retrieve an object, I do the same thing in reverse. Okay, so I've stored all my objects. Great. Now I have an outage. So what happened here? The state of the cluster changed. We rerun the crush algorithm on the placement groups that were affected. Hey, it's the red and the yellow that were affected. Automatically re-replicated to new OSD hosts. There's fancy rules for replicating things between OSDs. So if you have, say, 2 racks on separate power, you can not store both copies on the same rack. Here's the API again. Yeah, POSIX file system not ready because POSIX is hard. So we have a third type of server. We have the metadata server, which will so you do your metadata operations to the metadata server, and then your actual file data directly to the OSDs. So large chunks of data are not going to the metadata server. So the design goal is here is to be able to have and so for that, you want these to distribute load automatically. And so, well, if I'm doing small amount of I/O, okay, one can do the whole tree, but if there's a hotspot, the second metadata server can handle just that hotspot. And the idea is to store the metadata as objects in the cluster, so there's no local state of the metadata servers. They're just there to interpret the data for clients, also handle locking. They do locking stuff through they call capabilities. So a client will ask for capability on a file, and if another one needs it, it can't have that until the first one has relinquished it. More pictures of sharding. Sharding's hard. This isn't stable right now. Supported is one metadata server with some passive standbys. Fancy features, they do snapshotting. You wouldn't want to run a DF against a Ceph file system because it could take forever. But if you cat like the directory, you can get information. It does snapshots, everyone likes snapshots. It's not ready for HPC, but it's simpler than Lustre. But HPC environments are very specific. Most people right now just run Ceph with 2 gigabit networks, one public, one for the cluster. Not required, but cluster has all sorts of fancy interconnects. If you want to get involved with any questions.
Yeah,
Crystal ball.
You just said, so one public and one for the cluster. So what's the theoretical limit currently on number of nodes? You said they chat amongst themselves, so presumably at some point you'll fill up that gigabit link.
Right.
With chatter.
I'm not sure.
But bigger than anyone reasonably is going to be able to deploy in the next couple of years.
Yeah.
Okay.
Infinite.
Great. I mean,
Okay, thank you all for coming tonight. We are running very late, it's now 9:30. I want you to get out of here as quickly as you can and help us pack up and get out because we are going way over time. If you want to talk about anything after the meeting, please come to TriLUG, which is going to be at Farrow Wings, which same place as we've always had it. It's just around the corner, it's not far, it's just up near Mission Valley Cinema, up Avon Ferry Road. Thank you very much, good night.